Yes. All right, we start electromagnetism. First one, magnetic fields. Magnetic field is a region in which a magnetic force can be detected. So this is our first definition in this topic from grade 10, you know already. Magnetic field definition, number one. Number two, direction of magnetic field. Direction of magnetic field, we know already from N to S, outside of a magnet, outside of solenoid also coming. Solenoid, yeah, solenoid. So N to S outside, but this year we are adding new one inside magnet, inside solenoid or inside magnet, opposite to outside. People, please remember, this is important point. Inside S to N. All right, inside S to N, outside N to S. That's completing circle, as you see. N to S outside, S to N inside. And you see drawing magnetic field lines for solenoid most probably, because last year already we have done that, others. And then magnetic fields and current together. So we are using this dots, dot and cross. Dot and cross. So dot means out of page. That arrow is coming to you from page. So you will see examples now. And cross, it means into the page. Just that arrow is just going to the page. So you see just like that, 3D, let's show. And using your right hand. Yeah, this kind of questions. Okay, cross and dot, one of these they can ask. So if you see cross, so cross, just use your right hand, your thumb showing you cross. Cross means going inside the page. Your thumb is going to inside, going to the page, and your other four fingers showing you direction of current. So if you see cross, just you can keep in your mind. If you see current or magnetic field, cross, other one clockwise. Okay, X with clockwise. If you keep in your mind, it's going to be easy for you. X clockwise and dot anti-clockwise. All right, one of these is coming. You remember our multiple choice question also coming now. So magnetic fields and current directions like this, using your right hand. So some questions about this, please remember, maybe drawing, maybe just asking multiple choice questions, but we should know cross with clockwise and dot with anti-clockwise. All right, so this is our example one. So let's see, we answered already all questions. You can say we know already, but it's fine. We need, this is our revision lesson, guys. So now let's see, they're asking you which one is correct. Number one, is it correct, guys? Number one, check. Cross, what we said, cross clockwise, but now anti-clockwise. Or you can just use your right hand and try, just your thumb inside the page, and then when you see other four fingers showing you clockwise. But now number one is not correct. A is not correct. A is gone. So one is gone, sorry. Number one is gone. Number two, see, cross and clockwise. Yes, this is correct. And then dot and clockwise. No, this one also gone. And dot anti-clockwise, yes. Or with your finger, you can check dot, it's coming to you. Your task is going up, you're coming to you, and then your four fingers showing you direction of magnetic field. So this is current and asking you magnetic field. So now dot and cross showing you current, and other directions showing direction of magnetic field. Maybe opposite, it's fine. Same stuff. All right. I hope everything is fine so far. So this kind of questions. All right. In final exams, I took these questions from final exams. So from this booklet, too many questions you have for final exam. Of course, we are going to change. We are going to just make it some different, but this process, this stuff is going. All right. If you have any question, please let me know on chat. Let's continue. Yes, another question is here. Similar question as you see. Which one is correct? One more time. What we said, cross. Which one is correct? A, B. So check, dot It's supposed to be cross-clockwise, right? Cross-clockwise. Or you can just try our right hand. A, it's coming to you, your thumb is coming to you, just going up, we can say. Your thumb is going up, and because dot you have, and then 4 fingers showing anti-clockwise, but A is showing clockwise, it's gone. And then next one, cross into page. Yes, your thumb going to into page, and then you see clockwise. Yes, cross-clockwise. Maybe you can remember like that. Cross-clockwise. CC, starting with CC. Cross-clockwise, so B is correct. Others showing no, not correct. Answer is B. So we are gonna just have this kind of questions. Yes, magnetic field around the solenoid. So now, guys, you remember a magnet from first page. So this one, just think you have a solenoid just like a magnet, but polarity will be different. Which side is N, which side is S will be different. You are going to have different. For example, now you see this side N, other side S. And then inside, just magnetic field moving S to N. And then when you come outside, N to S. Maybe magnetic field direction you will have, and then they're going to ask you polarities. Maybe just like that, you know. Or they can give you polarities, ask you draw magnetic field lines. But what we know, what we have to remember, outside magnetic field lines N to S, inside S to N, just like that. Let's see another question. Yes, we asked, I think, this question on September test. So now they're asking you, draw, okay, what is given? Dot is direction of current and solenoid is here. And they're asking you, draw magnetic field lines. All right, so dot is easy one, you know already. Dot will be anti-clockwise. Yes, you are just drawing that. But when you come to solenoid, how we are gonna draw? How we know polarity? As you see, NS is not given. NS not given. So how we are gonna work out and how we are gonna get it? Let's explain now. So this one, starting with direction of current. Okay, direction of current, we should remember from positive to negative. All right, direction of current from positive to negative. For battery, as you see, we have positive side, this one. So current moving like this. Okay, starting with direction of current. And current going up behind this rectangle, so behind this metal, let's say solenoid, is going up. When you come front, as you see, it is going down. So one more time from behind, going up and then going down. So which face you see, it is going down. All right, so this is important one. So direction of current going down. Now, you are using your right hand one more time. I will try to draw a hand here. So your 4 fingers showing you direction of current. All right, your right hand, just put your right hand down, your 4 fingers showing you direction of current. If it is your right hand, so your thumb will be this way. So your thumb showing you, sorry for ugly hand. So your thumb showing you direction of magnetic field. So 4 fingers. So how can we change this question? Just change batteries, you know, just positive, negative, and then everything will be different. Now, so inside what we know, this one showing you direction of magnetic field. Okay, inside what we said, direction of magnetic field from S to N. From S to N, we know that. Okay, let's just clear it. Looks like N, but it's that direction of current. So this one is S, this one is N. How we are getting it? Starting with direction of current, number 1. Direction of current from positive to negative, and then we said behind is not our job. Okay, which side, which one you can't see, it's not our job. Which one, which face you see, that side is important. And then you see it's all going down. So if all going down, what's gonna happen? So your 4 fingers showing you, oh, you said BB, sorry. Okay, let's clear this one, direction of current. So this one, your 4 fingers showing you direction of current. As you see, direction of current is going down. and then magnetic field to the right. So inside the solenoid, you are drawing direction of magnetic field to the right. And then what we know inside the solenoid or magnet, so you are making magnet now. All right, you are making a magnet. So inside S to N, inside S to N. So now you have polarity for a magnet or for a solenoid. You have polarity inside N to S. What they said, draw your magnetic field lines outside or inside. They didn't mention, but it's fine. Let's draw outside N to S. Now, just like a magnet, you are drawing direction of magnetic field. I hope it is fine. I hope you are getting it. So now I'm going to just change that, and then you are going to see differences between. So when I change questions, okay, let's draw here. Let's show. Let's give you another question. But let's show answer first. For this question, I hope everything is fine. So let me check. Yeah, N to S direction like that. So if we change this question, how we are going to change? Now, same stuff, same solenoid. Okay, let me change on the system. It's going to be much easier for me. So let's change. Now you have battery, this side positive and other side negative. Let's make it longer, this side. Okay, same question, but now we change direction of current. If you change direction of current, what's going on? Just all current getting other sides. So current moving from positive to negative. From positive to negative, but it was going other side, right? Now it's going this side. So what phase you see? Current going up. Now going up. So behind is going down, but it's not our job. Now going up, as you see, all everything getting different. So going up, going up. I hope it is clear now. I hope you are getting it, because I want to ask something like this. All right. So it is going up, and then you are using your right hand. One more time, our ugly hand coming. So 4 fingers, your right hand, 4 fingers showing you direction of current, but now they are going up. If it is your right hand, put on the screen or put on the page, what you are going to see, your 4 fingers going up and your magnetic field going to left. All right, your magnetic field, your thumb just showing. It is worse now. Okay, so now this is direction of magnetic field. This is these 4 fingers showing you direction of current. And then what we know inside direction of magnetic field, B, this side. Now to the left. So what we know inside a magnet, direction of magnetic field always from S to N. You remember just N was here, S was there, but now just opposite direction. And then we are drawing our magnetic field lines outside, N to S. I hope everything is fine now. So this is important one for our electromagnetism questions, because there's no calculations, only this kind of questions, drawing or just showing direction questions. All right, if you have any question, please let me know. All right, if you have any question, please let me know. And we are going to carry on with our next question. So using one more time, revise. Electrons moving from positive to negative, and then you start from positive side, and then you check on the solenoid what we have, which direction, but which phase you see. Which phase you see, you are using that direction of current, and then you are using your right hand and put on the page your right hand, 4 fingers showing you current, direction of current, and then your thumb showing you direction of magnetic field, and then you are going to inside magnetic field S to N and writing polarities. When you write polarities, after that easy to draw direction of magnetic field. I hope all sharp. We can carry on with next question because there's no question from you. It means everything is fine. If there's no question, there are two options, guys. First one, you are getting everything. Second one, you are getting nothing. So, but I know you are getting everything. So we have done. All right. Now another thing. Okay. Now you have a solenoid, but there is no battery, nothing. So how you are gonna know polarity for solenoid? Now we have one rule. Oh, sorry, two rules. First one, if this magnet is going away, they are gonna have opposite polarity. So magnet, what we have here, we have S, right, for magnet, and for solenoid, it's gonna be N. If it is going away, they are gonna attract each other. They are gonna have opposite polarity. So now this is N, this is S. So you are getting polarity like that. Okay, let's explain again with, let's show both of them. If you have a solenoid like this is Lenz law, people. So you have solenoids, small anyway, just carry on down. Okay, you have solenoid, but there is no battery, nothing. Just magnet is coming closer or going away. Now let's say coming closer. If it is coming closer, if you have S here and your solenoid also S. Okay, if coming closer, they have same polarity. Coming same. Just you can keep in your mind like that. Coming same polarity. If it is going away, so let's draw your solenoid one more time. Just make simple one, it's fine. You have solenoid, but there is no battery, nothing, but a magnet is coming, but maybe magnet coming from other side, it's fine. All right, you have, let's say, NS, but now going away. If it is going away, they are having same polarity, S. All right, see, coming, wait, we are lost now. Okay, so if they are going away, opposite, sorry, this one is wrong. Okay, if they're going away, opposite. What we said, coming same, going different. Okay, coming same, going different. So you can confuse with this one, but if it is coming, they are gonna repel each other. Repel means they have same polarity. If it is going away, something is going away, just you don't want to lose it, so you want to just catch it because of that different polarity, they attract each other. This is N, this side is S. When you get polarity, they're asking you different questions. Maybe they're asking you polarity, so direction of magnetic field inside, or polarity for left, polarity for right. We can change questions, you know. But what we have to know, when it is coming closer, they repel each other, they have same polarity. When it is going away, they attract each other, and they have opposite polarity, Sn. So let's write here just in case, otherwise we are going to forget. Coming, if it is coming, same. Okay, coming, same polarity. Let's write, because this is important. So one question, minimum 2 marks question about this. We can change question, they can do too many differences, but using this, all right. So going, next one, going different polarity. So going different polarities. So just remember these two, and then we can answer our questions. Okay, let's see this question now. It is going, right? Going different, all right, but just not at this one different, all right? Which one close to polarity? Which one is close to solenoid? Now S is close to solenoid and going away. So they are different. So this is N, this is S. And then we know polarity. And then what we know inside the magnet or solenoid, we can say it's fine because you are making magnet. So magnetic field here, inside, outside, just like this. You don't have to draw, just to see what's going on. Let's see question what they're asking. Which one of the following correctly describes the direction of current? Okay, so how we are going to get direction of current for this? Now, one more time, you are using your right hand. Remember, from current to magnetic field, we are using our ugly hand. One more time. So now you are starting with your thumb. So thumb is here, and then your right hand. So your four fingers this side, each drawing getting worse. So now, as you say, your magnetic field this way, current going up. But which one is going up? Which side, which face you see? The current is going up. Going up means, so you say, but this one is not clear because this they shouldn't put here the line, so it's fine. And then this side is going up. Front is going up. If front is going up, behind is going down, and then when you come here, it's going down, and then X is here, so, and then when you come this side, it carry on, and now it's going up. So we can say, just remove this, all right? So we don't need this side, because otherwise X to Y, Y to X. On the solenoid, we should talk about, so Y to X, all right, Y to X we can say. And then polarity of left and the coil. So left side, what we have, N we have, and so we can say Y to X and N. So we should change answer, Y to X, N. So if you put a conducting wire here, it's gonna be maybe X to Y, Y to X. So we are gonna confuse for that, but leave it, it's fine. So just remember showing, using your right hand, and then right hand, four fingers showing direction of current, and your thumb showing your magnetic field. Now what we have, magnetic field we count, we get from this one. When it's coming closer, same polarity. When it's going away, different polarity, we know that. And then inside the solenoid, S to N. So you must just work on it, and you must check what they ask. This confusion because of this conducting wire, but now we know as you start from Y, so we can say Y to X is fine. All right, just because from Y to X, or going on solenoid and coming back, and then face as you see up, and then polarity left and polarity right side is S. So you can just check which one is better, which direction. So we have done this question. Let's carry on. We have more questions. All right. Let's see. Faraday's law, yes, we should know. What definitions we have? Faraday's law, Lenz law, and then magnetic flux and magnetic field. Okay, we have 4 definitions only. Minimum 2 of them is coming. All right, just make sure 4 marks coming from definitions, 4 marks coming from drawing, and then nothing else we have. Drawing, and then, you know, just coming, magnet is coming closer. That one we should know. So let's continue with other questions. This one is not clear because we don't have which one is behind, which one is, so, you know, we can leave it. Magnetic flux, yes, another definition. Please just study all definitions. Magnetic flux is the number of magnetic field lines which are passing through the cross-section area. So for example, for this one, we have 6 magnets, but we are not busy with numbers. Don't worry about that. But just remember definitions. Please don't lose your mark because of definitions. All right, you know already, just on Tuesday also, I will revise just all topics, what definition we should know, and then everything one more time, I will explain to you. But please make sure, and maybe you can make your list, you know, you can write it down again, and you can check. So just like that, don't lose your mark because of definitions. If you lose your mark because of definitions, I understand, I see you don't study. All right, don't tell me you did study. Well, no, you didn't study. All right, Lenz law is another one. Lenz law definition is long one, but Lenz law direction is we can write only. But let's see. Lenz law gives direction in this. Which one is better for this? Okay, from memo, I will share on daily questions also. When magnetic flux will show current, yes, this one we can use. Lenz law definition is here. Oh, oops, sorry. Lenz law, we are using our definition. That one will be enough for Lenz law. Faraday's law. Okay, yeah, this one is Lenz law. Please remember, we have Lenz law, Faraday's law, magnetic flux, and magnetic field. From last year also, you know magnetic field definition. All right, please just revise Lenz law, here. Just if you use this, will be enough. Let's continue. Yes, coming closer, and then do you remember? Just we explained already in our question. When it is coming closer, they are having, as you see, repulsion. Repulsion means they are having same polarity, N, N. This side is N. But you will not have like this. You will have with a metal inside like this, and then you are gonna make sure which one is front, which one is, which face you see, which one which behind that, and it's gonna be clear. It's gonna be much easier for you. So when it's coming closer, repulsion, they have same polarity, as you see, N, N. So when it is going away, so let's work with this one. For example, now it's coming closer. If it is S, this side is what we said. If coming closer, they are having same, coming same. Now SN. If it's going away, we have N this side, S other side. And then what question we can ask? Left side, polarity of left side solenoid. What's that? S. So polarity of right side solenoid, N, for figure 1. For figure 2, maybe we can give some this figure and then we can make question for you. So, and then going away, so polarity left side for figure 2 is N, and then polarity right side for figure 2 S. And then what is inside magnetic field for figure 1? What's that? Left to right. Yeah, to the right, because inside magnetic field this way, and then magnetic field for this one, so this way to the left, because S to N always. If you need to draw magnetic field lines outside, also you can draw, because outside N to S we know. All right, so this kind of questions coming, guys, please be ready. So next one, direction of current. Okay, explain the reason for direction of current in the figure. Okay, it's fine. We done already all. Clockwise, anti-clockwise, or Lenz law. Okay, let's do other ones. Faraday's law is next. Faraday's law definition is here. Okay, EMF is directly proportional to the number of turns. Yeah, we are using Faraday's law to explain some other things when you want to get more current. You know, you are using current to make magnetic field, to make more magnetic field. So number of turns important. Number of turns important. Number of turns. You must just, if you increase number of turns, you are getting more current. All right. Or you are using current to make magnetic field, you are getting more magnetic field. So if you just decrease number of turns, you are getting less current, or you are getting less magnetic field. Just know that. And then magnet is coming closer, but if it's coming faster, you know, just moving faster, so making more current. All right, just remember that is all list we'll have. So let's see another question we have. So we'll try to ask all questions from Lenz law definition, and one question from Lenz law. Faraday's law definition, and one question from Faraday's law. And then magnetic flux. There's no definition for magnetic flux, but at least definition. There's no calculation, but definition we should know. And then solenoid also coming. Okay, 1.9, another question. And coming, yes, approach to A, all right. And then which one of the following says about polarity A and B magnetic field? All right. We asked similar question on your September test. Now, polarity A, what is that? Polarity A is N. Why? Because it's coming. What we said, coming, same polarity. B is S. It is our first thing we know. And direction of magnetic field inside what we know, it is going to B to A. So our question is what? Polarity for A, N, yes. B or, what's that? N, what we have, B or C, yes. And then direction of magnetic field, B to S, yes. Answer is B. But if I ask you direction of current, what you are gonna say? If I say direction of current and then I put here X and Y. So what's gonna happen? Direction of current. Okay, one more time using your right hand. Ugly hands coming again. So right hand, we are using your thumb showing you direction of magnetic field, we said, right? So current going up. This side, this phase, which phase you see, current going up, 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 up. So it means X going up and out behind is going down. And when you come for Y, it's going Y. So we can add another equation here, direction of current, X to Y. I hope everything is clear. We just combine two questions and then getting magnetic fields and current direction also. And they can ask you same, okay, similar question, and then asking you draw magnetic field lines from N to S. You can draw inside S to N, outside N to S. I hope everything is fine. Let's continue with next one. Let's see what else we have. From now, just repeat questions, similar questions. Magnet is coming closer. Faraday's law, yes. They're asking Faraday's law and state two ways which deflection of current can be increased. It means to increase current, what can we do? They're asking you, okay, so this is also important. What we said, to increase magnetic field, Faraday's law is here, you can just use any of this. And then to increase, oh, didn't give answer. Okay, so to increase magnetic fields, to increase current, let's say, because you are coming with magnet, to increase current, please remember, increase number of turns, and move faster magnet, or put a metal inside the solenoid. You are putting just a metal inside. So we have three options. It was written somewhere. Let me just check. It's here, or okay, let's show that one. If it's not there, I can just go up. From now, similar questions. Quickly, I will show last minute, and then but all list I have to show you. I must show you. Where is it? Okay, start with no definitions. How can we show? I know it was here. Yes, it is here. The strength of magnetic fields or get more current. So current increases, number of turns increases, and placing bar adjust iron solenoid. So increase current, or to increase current, increase magnetic fields. Okay, opposite, just think opposite. You want to make magnetic field, you must just increase current. All right, or you want to make current, you must increase magnetic field. So it is number one, increase current. And the number of turns, increase number of turns. And then placing a bar of iron on solenoid. Okay, we have three options. On September test, we ask this question. Please highlight on your booklet. So this is important one, another one. All right, from now. So we done which question? This one we have done. From now, just repeat question. They're asking you which one is correct. A is correct because coming closer, and others wrong. And then C, this one about that question. Increase EMF. Rotating slower? No. Increase EMF means increase current, guys. Decreasing number of turns? Of course, no, because we said it must increase. Increase speed of rotation? Yes. So changing polarity will not help you, just changing direction. All right, so this is good question, 1.9 about our topic. And then another question here, N is given, X is there. So if it is coming close, what we said, they have same. This is N, this side is S. And then asking you which just asking you polarity for X with N, it is north, and then direction of current. Okay, so now we are using our right hand, ugly hand, maybe you remember ugly hand. So you can draw, or you can just put your hand down on page. So we have S to N, right? Magnetic field, and current going up. First phase, what you see, just going up, 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 up. So behind is going down. When you come to its B for going down, for A it's going up. As you see, first one is going. As you see, direction of current from A to B. I hope it is clear. We just revised our topic. So from now, you are going to study. Let's see any other question. Sorry, time is over, but I came late. Sorry, just one more minute. Let's finish. This is another question. Oh, same question we have done already. Induced current just look equal to. So this is our question about, just this answer is D. You can just memorize that. And this is similar question as you see for cross clockwise, and done. Yes, now done. Thank you very much. See you next lesson. Have a nice day. Now you can take your break. Thank you. Oh, yeah. Yes, all good. Thank you very much. I hope you understand. Everything is sharp.